Here is another problem that you're going to be asked to work. The wording is sort of goofy, but once you see the problem, the wording is much worse than what the problem looks like. They say a point on the terminal side of an angle theta is, in this case, I'm going to use -3, 4. So by that, just so you know, this is like a point on an XY graph. X -3, Y 4. Find the exact value of the 6 trig functions. So here's all they're saying. I'm going to graph this point. So -3, 4 is like right here. And they're saying basically here's your angle, and they want to find the trig functions for this angle. Now, I'm not going to go into detail to explain why this works, because it would maybe take 10 or 15 minutes, and I know the goal here is for this video just to explain how to work out these problems. But you just have learned about reference angles, and here's another problem where reference angles allow us to make this problem fairly straightforward. So although this is my angle here, the way you work these kinds of problems is I'm going to go ahead and I'm going to form a right triangle over here. I'll just denote this as the reference angle. But I am now going to go find the trig functions of this angle here because I have a right triangle. So I'm going to be able to use my right triangle trig functions to find the 6 trig functions. And that's actually going to be the answer to the trig functions of this. Now the key is I'm going to use this right triangle in a minute to figure out the 6 trig functions, and I should say to figure out the numbers. The values of the 6 trig functions. However, after I figure out the values or the numbers for the trig functions, I then have to attach whether it should be a positive or negative number. And that's going to be dependent upon which quadrant we're in. Hopefully you can see we are in quadrant 2 here. So after I go figure out the numbers for each of the 6 trig functions, I then have to go check and say, okay, for the sine in quadrant 2, what should it be? Positive or negative? For the cosine, what should it be? Positive or negative? For the tangent, what should it be? Now we're going to do this problem and you're going to see that, but I just want to give you a heads up that it's really getting these answers, finding the 6 trig functions is really a 2-step process. The first step is you get the actual numbers, and then the second step is you decide whether it should be a positive or negative answer. So let's go ahead. So now I can create this right triangle. If this is my angle here, of course we think of this as the adjacent side. We think of this as the opposite side, and this is the hypotenuse. Now if this point right here is -3, 4, this distance here, the adjacent side, that distance is 3. Now I'm not worrying about, well, it's really -3. No, I just want to know the distance. I'm not worrying about positive and minus signs. I just have this triangle here. The adjacent side is a length of 3. The opposite side is a length of 4. And now, using the Pythagorean formula, right, if I know these two sides, what we call 2 legs of a right triangle, I can find the hypotenuse, right? 4 squared plus 3 squared, 16 plus 9 is 25, and the square root is 5. So the hypotenuse is 5. So here, I have a right triangle. It's one of these 3, 4, 5s. So I can simply go over here and start finding my trig functions, right? The sine of theta, opposite over hypotenuse. So here's the first step. I get the numbers, 4 over 5. But then I have to go say, okay, in quadrant 2, is the sine a positive or negative number? Well, in quadrant 2, if you think of sine, sine tracks y. Sine is like y. Y is positive in quadrant 2, so the sine is going to be positive. Let's do cosine next. So ka, adjacent over hypotenuse. Adjacent 3 over hypotenuse 5. So the number is 3/5, but then I say to myself, in quadrant 2, is the cosine a positive or negative number? And in quadrant 2, since cosine is like x, x is negative in quadrant 2. So I have to go make the cosine a negative number. Tangent, so-called TOA, opposite over adjacent. The number is 4/3. Now, is tangent, what is tangent in quadrant 2, positive or negative? Well, since tangent is sine over cosine, since sine's positive and cosine's negative, positive divided by negative is going to be negative. Tangent is actually negative in quadrant 2. So these are the 3 main trig functions. So I got these all from my right triangle trig, and then also knowing that my angle's in the second quadrant. So if I get the remaining 3, now I can just do what I always do and take the inverses or the reciprocals. So sine is with cosecant. So you just flip this. Cosecant will be 5/4. Cosine is with secant. So we reciprocal this, and now the sine, the plus or minus is going to be the same. So if cosine's negative, secant's also going to be negative. And the reciprocal is 5/3, so the secant's negative 5/3. And for cotangent, cotangent is the reciprocal of the tangent. Since the tangent's negative, the cotangent is also going to be negative. So that's how you do these problems. Let's do another example. How about the point we're given is 2, -5. So we're going to plot that point, and then we're going to create a right triangle, and then we can go from there and figure out the 6 trig functions. Excuse me. So let's go ahead and see what we've got. So x2, y -5. So really, in a literal sense, the angle we're looking at is this right here. But, like I said a minute ago, the power of reference angles allows us just to create a right triangle over here and use this right triangle. If we find all the trig functions of this reference angle, that's going to be the answer for all the trig functions of this original angle. So once again, This is why reference angles are very important. So first thing we do is just figure out the sides of this right triangle. So obviously, this is going to be the opposite side, and it is a length of 5. Here's the adjacent side, which is 2. So the hypotenuse, in this case, is going to be square root of 5 squared plus 2 squared. Looks like the hypotenuse is square root of 29. So now we have the 3 sides of a right triangle. So now we use our trig definitions of a right triangle. Now the key is we are in, this angle is in quadrant 4. So after we go find the values or the numbers for each of the trig functions, we then have to decide whether it should be a positive or negative number. So sine is opposite 5 over hypotenuse square root of 29. Now in the fourth quadrant, is the sine a positive or negative number? Well, sine tracks y. Y down here is negative. So it's actually going to be negative. Matter of fact, while we've done the sine, let's just go ahead and do its, what I call its partner or its buddy, because it's just going to be the reciprocal. So square root of 29 over 5, and it's also negative. So the cosine, so ca adjacent over hypotenuse. Now in quadrant 4, is the cosine a positive or negative number? Cosine is like x. In quadrant 4, x is actually positive. So the cosine is going to be positive. And now we can easily get the secant by taking the reciprocal. And the secant will also be positive. And then finally, tangent, so-called TOA, opposite over adjacent. Now in quadrant 4, is the tangent positive or negative number? And if you compare sine and cosine, since sine's negative, cosine's positive, therefore the tangent is going to be negative, and therefore the cotangent is the reciprocal, and it's also going to be negative. All right, so when you have these kinds of homework problems, hopefully you will not find them too difficult. You're basically just going to create right triangles and then use our trig definitions.